Let's do a bit of adding and multiplying with the vectors in this video. I have a scene called character orientation scene. It's an empty scene with nothing but the default camera and the lighting, and I've imported a character. And if you look at the character orientation, so this blue arrow is the forward of the character, the red arrow is the right, green is the up, and in a Unity transform for each of the game objects, these directions are represented by a vector, each with a magnitude of 1. So you can say they're normalized, one with the forward direction, right direction, and with the up direction. And obviously as the character rotates, these three directions will change accordingly. Or as the character moves, so do these orientations. For example, I'm going to create a sphere, put it at 0, 0, 0, and let's make sure that the character is at 0, 0, 0, no rotation in the beginning. And I'm going to create a script called ybot. I'll just call it ybot. Go in there. And let's say we want to place the sphere in the forward position of the player. First we need to get the sphere, game object sphere, and we get the character position. And if we add the forward and multiply that by 3, for example, this would be like getting the player position and its forward, which is a normalized vector with a magnitude of 1. If you multiply that by 3, we get a new position somewhere in front of the character with a distance of 3. So that would be the position of the sphere. And since this is in the update function, which happens at every frame, the sphere's position is going to change according to this equation. So if I set it up in the ybot script, well, we got to add the script first. Ybot, put in the sphere, and I'm going to click play. Okay, so here's the sphere, 3 units away from the player position in the direction of the player's forward. And if I start rotating the player, that relative position is going to change, and that's where the sphere is going to be. And obviously we can do this with every single other directions from the player. So this is the forward. If you multiply a negative number, we would be going this way. Right side would be here, up will be going up. So if I go back to the code, and if I change this to transform up, I think it's pretty clear what's going to happen. So here's the sphere. Okay. Or negative up, which is down. Okay. One little trick that I use in my game, the 2.5D platformer, let's say we have an object in the scene, and this object could be either on the right side of the player, so this is right, or it could be on the left side of the player. And let's say that the player position is A, the box position is B. If we do an A minus B, we're going to get a vector that goes this way. We can see that the distance away from the player is 3.3. So the vector from B to A will look like 0, 0, negative 3.3. Now this Z being a negative number means that the box is on the right side. If the box were on the left side, somewhere here, this vector would look like 0, 0, positive 3.3. So for my 2.5D platformer, where everything is based on a single axis, where everything happens on Z, it's quite easy to figure out where an object might be in relative to the player. Or if the player's facing this way, his forward would have a positive Z, while if the player were facing this way, his forward would be a negative number. So for my current project, for the relative position of any object compared to the player, it could only have 4 different cases where player is facing forward and the object is on the right side or the left side, or if the character is facing the other way and the object could be on the right side or left side. And this is one of the reasons why I'm doing a 2.5D platformer instead of a full 3D game, because I'm an indie game developer and I'm working on this alone. I would have a lot more work to do if everything were not based on Z, but instead, since everything is fixed on a single axis, you can do most of the calculations through simple vector arithmetics. And I think that's pretty much it for this video. If you have any questions, you can reach me on my Discord server. I have all the links below. And in the next video, I think I'm going to talk about vectors in terms of raycasts, and I think that might be the end of the series. Okay, so thanks for watching. I'll see you next time.